As the application grows, the database layer becomes the most critical and the most operationally demanding component of the stack. Handling replication, failover, backups, patching, and scaling across environments introduces complexity that can slow down teams and increase risk. Architecting for reliability isn't just about provisioning a single database instance. It requires a database foundation that is resilient, secure, and designed for high availability from the start. Hello everyone, I'm Sanskriti Harmukh, a developer relations at Vultr, and in today's Tech Talk, we will explore how Vultr's managed databases for MySQL eliminate operational overhead by providing managed replication, automated backups, and high availability out of the box. We'll cover the underlying architecture, practical use cases, and a live demonstration of deploying a MySQL database cluster on Vultr and connecting an application to it. So, to see it all in action, let's dive right into it. Vultr Managed MySQL gives you production ready database clusters running the InnoDB storage engine, which provides asset compliant transactions and robust data integrity. You can deploy single node clusters for development or multi node clusters with standby replicas for high availability. When configured with a standby replicas, Vultr uses continuous asynchronous replication from primary to replica nodes. If the primary fails, Vultr's High Availability Manager detects failure, promotes a standby replica to primary, and maintains the same connection endpoint. Applications using connection pooling with retry logic automatically reconnects to the new primary with minimal disruption. On the operational side, automated backups run with point-in-time recovery capability and provides integrated monitoring that tracks CPU utilization, disk input output, and network throughput, which you can fetch from the Vultr Customer Portal, API endpoints, and CLI commands. This eliminates the need for external monitoring infrastructure while giving you the metrics needed to identify bottlenecks and make scaling decisions. The key is that replication topology, failover orchestration, backup scheduling, and metric collection all runs without you provisioning or managing the underlying infrastructure. Now, let's pause here and visualize exactly how this works. When your application connects to the Vultr Managed MySQL database cluster, it does so over a TLS encrypted connection using the database endpoint and credentials provided by the platform. In a typical production scenario, your application server runs inside a VPC and establishes a secure client session using the standard MySQL drivers. Behind that single endpoint is a primary replica cluster, where the primary node handles writes and the replica node receives asynchronous replication updates from the primary node, like discussed earlier. Now, around that connection, the operational layer is fully managed. Automated backups run at scheduled intervals with point in time recovery enabled. So, if an application deployment introduces bad data at 2:32 pm, you can restore the cluster to a precise timestamp before the issue. Integrated monitoring continuously tracks resource utilization metrics, giving you the data required for performance tuning and scaling decisions. Security controls, on the other hand, enforce TLS encryption in transit, encryption at rest, and network isolation within your VPC. As workload demands increase, you can vertically scale resources without manually reconfiguring replication or migrating data. Let's further explore how Vultr managed databases for MySQL with several production use cases where database reliability and operational simplicity are critical. Web applications and content management systems like WordPress, Drupal, or custom CMSs need reliable MySQL for handling user sessions, dynamic content rendering, and metadata storage, as they generate mixed read write workloads with unpredictable traffic spikes. E commerce platforms depend on transactional integrity for shopping carts, inventory management, and payment processing. The InnoDB engine's asset compliance ensures that financial transactions either complete fully or roll back cleanly, while automatic backups with point in time recovery provides a safety net needed for regulatory compliance and fraud investigation. SaaS applications with multi-tenant architectures often serves a large pool of customers from the shared infrastructure, requiring a database layer that scales reliably without manual intervention. Vultr Managed MySQL database handles this by letting you focus on application logic and tenant isolation at the schema level, while Vultr handles backups, replication, and availability. API backends in microservices architectures break monolithic applications into distributed services, each potentially requiring its own database instance. With Vultr, you can spin up MySQL clusters via API or CLI, get production ready database instances, and avoid the operational overhead of managing dozens of individual MySQL clusters. With use cases and benefits now covered, it's finally time to see it all in action. In this demo, we'll deploy a Vultr managed MySQL database cluster connected to a live application and run actual database operations. Then we'll switch to the Vultr customer portal to see query execution in real time and explore capabilities like automated backups, read replicas, and cluster management. This will show you how teams eliminate database operational overhead and ship features faster. Let's start by provisioning a Vultr managed MySQL database cluster. To do this, open the Vultr customer portal, navigate to the databases section under products, and here click Add Managed Database. You can begin by selecting MySQL as a database engine. The latest version available here is MySQL 8, which provides modern features including improved performance, JSON support, and better security defaults. For server configuration, Vultr offers different compute type optimized for various workloads. We'll go ahead with optimized cloud compute type with a plan that provides one virtual CPU, 4 GB RAM, and 30 GB of NVMe storage. For high availability, you can configure up to 2 standby replicas for automatic failover. Each replica is a complete copy of the database running on the selected infrastructure. For this demo, we'll stick with one. Next, select a region closest to your users or application servers. This in turn will minimize latency. You can also configure a VPC by selecting a VPC already created in the same region. This will isolate the database on a private network. For now, we'll skip this configuration. But if you would like to know more about Vultr VPCs, you can refer to our product documentation or the tech talks demonstrating the use cases from the description. Lastly, provide a label for easier identification of the MySQL cluster. Once done, click Deploy Now. Now that the cluster has been provisioned and is successfully running, let's click on it to open its overview page. Here, scroll down to the connection details section, as this contains everything you need to connect your application to the MySQL cluster. Notice that a default database called default DB and an admin user Vultr admin has been created automatically upon provisioning. These credentials are ready to be used immediately with no additional setup required. So copy the connection string as they will be required by the task manager application we will spin up next to interact with the MySQL cluster. Now, to continue, we can simply switch to our workstation to carry on with the next steps. Here we'll start by cloning the repository and switching to the directory where the application code resides. This contains a simple Node.js task manager application using which you can add tasks, mark them as complete, edit them, and delete them, all backed by our Vultr managed MySQL database cluster. Inside this repository, we have a .env.example file, which is a template for environment variables containing database connection parameters. Complementing that, we have db.js, including the database connection configuration that creates a MySQL connection pool using the credentials from .env. Setup.js, on the other hand, is a database initialization script that creates task table and inserts sample data. This need to be run once before starting the application. Then we have an Express.js backend server that defines REST API endpoints for CRUD operations on task. This handles all database interactions. Finally, the public directory contains the front-end assets. This follows a standard 3-tier architecture that you are already familiar with. Now, before installing the dependencies, ensure that Node.js and npm are already installed on your system. You can verify this by running these commands. If they return compatible version numbers, you're good to proceed with. Finally, let's install Node.js dependencies defined in package.json. This installs Express for the web server, MySQL 2 for database connectivity, and .env for environment variable management. Now we create the .env from the template, then edit it to add actual database credentials. Update these values with the connection details copied from the Vultr customer portal. Once done, save the credentials and exit the editor. Further, let's quickly look at how the application connects to the MySQL cluster. db.js creates a connection pool using the MySQL 2 promise library, which in turn maintains a pool of database connections rather than creating a new connection for each query. This dramatically improves performance and resource utilization. Wait for connections is set to true here, so if all connections are in use, new requests wait instead of failing immediately. This is critical for handling traffic spikes. Connection limit, on the other hand, allows a maximum of 10 concurrent connections. This prevents overwhelming the database while allowing reasonable parallelism. This indicates the pool automatically manages the connection lifecycle as needed. Now let's run the setup script to create the database table. This script acquires a connection from the pool, creates the task table with the defined schema, checks for existing data. If the table is empty, it inserts sample task for demonstration and releases the connection back to the pool. Notice that the output confirms table creation and sample data insertion. The database is now fully initialized and ready for the application. Let's also switch to the Vultr customer portal to see exactly what just happened behind the scenes. In your MySQL cluster, switch to the Queries and Logs tab and view the recent statistics section. Here you'll see the actual SQL queries executed for creating the tasks table and inserting the sample tasks to it. You can also check the recent log section to see the connection from our application to the database, including the SSL-TLS encrypted session. Now let's proceed with starting the Express server. The server loads the environment variables from .env, initializes the connection pool to the provisioned cluster, defines the REST API endpoints, serves the static files from public directory, and listens on port 3000. Each endpoint defined uses parameterized queries to prevent SQL injection attacks when handling user input. For production deployments, you would typically expose the application through your own domain and configure HTTPS with a TLS certificate. Now that the application is running, let's verify the connection by opening the provided URL in the browser. Here notice the tasks we inserted via the setup.js script are now displayed in the interface. The data persisted in MySQL and is retrieved through a select query and rendered here. The web page also shows our current state. Total 4 tasks retrieved from the database, 2 tasks marked as complete during setup, and 2 tasks still in progress. Let's now interact with the application. You can clean up the completed task by clicking Clear Completed. Behind the scenes, this executes a delete query for each completed task and remove them from the table. Next, let's add a new task. Type in the input field, for example, publish tech talk for Vultr Managed Databases for MySQL, and click Add Task. This sends a post request to the Express backend, which executes an insert into task SQL statement. Let's now modify a task. Click Edit on any task, change the text, and click Save. This executes an update query, modifying the task text in the table while preserving task ID and other metadata. You can also mark a task complete by checking the checkbox. This sends a put request that execute an update query, setting the completed column to true. You can click delete on any task to remove a specific one, or click delete all button for bulk operations. With that, let's switch back to the Vultr customer portal to further explore the capabilities of Vultr Managed Databases for MySQL. Under Recent Statistics, if you now click Refresh Statistics, this will populate the new queries that were executed behind the scenes, the number of times they were called, the average number of rows that were affected or returned, and the minimum, mean, and maximum response times. You can also check out Usage Graphs tab. This provides visual insights into your cluster's resource consumption and performance. At the top, you will find current resource utilization, how much space your database is consuming, plus the RAM usage. Below that, you can view historical metrics over different time periods. The graphs display CPU utilization percentage over time, read and write input output operations per second, and inbound and outbound network traffic in bits per second. Next, let's navigate to the Users and Databases tab. Here you will find a default user called Vultr Admin, which is an administrative user with full privileges, and a default database called Default DB, acting as your primary application database. You can also add additional users and databases as your application grows. Once created, they will be reflected here for you to maintain. You can copy the connection strings for any combination required from the overview page. Now let's talk about the Migration tab. It provides ways for importing existing data to your created database cluster on Vultr. This supports two scenarios. First, one-time migration. If your source database doesn't support replication, Vultr uses MySQL dump to export the schema and data and import it to your Vultr managed cluster. Second, continuous replication. If your MySQL server has binary logging enabled, Vultr can set up MySQL replication to synchronize your source database with Vultr managed cluster in real time. Make sure the labeled requirements and expectations are fulfilled before proceeding. This ensures a smooth migration and prevents data inconsistencies or connection failures during the transfer. Next, let's come to the Settings tab. This provides control over the operational parameters. Here, you can configure when the maintenance updates apply by selecting the day of the week and the start time. Please take into account this important note here. Also, during maintenance, your application will experience a brief disconnection as connections will fail over to healthy nodes. But with proper connection pooling and retry logic, this is transparent to users. So, it is always recommended to schedule maintenance updates during your application's lowest traffic spikes to minimize impact. Next is backup configuration. You can set a custom backup time, and Vultr will take automatic backups daily along with binary logs for point in time recovery. The settings page also lets you set the default time zone for MySQL operations timestamps. You can even control MySQL's SQL syntax validation and behavior through global SQL modes to ensure data integrity and SQL standard compliance. Using advanced configuration, you can fine tune MySQL parameters for your specific workload requirements. If you would like to scale your cluster, you can do so by upgrading to a more powerful hardware. On top of that, you can even migrate your cluster to a different region to be closer to your users or meet data residency requirements. Now, back in the overview page, the action section provides more powerful operations. For example, let's talk about restore from backup options. You can either restore from the most recent automated backup or restore to any specific time within the retention window. The original cluster remains running during restore, ensuring zero data loss. You can also fork database cluster to create a complete independent copy of your cluster. When you click on it, you will be asked to either fork from the latest backup or a specific point in time, giving you the flexibility in which state to clone. Vultr then uses the selected backup, provisions a new separate cluster, and provides a new connection string for the fork. You can also add a read-only replica node to scale the read capacity. Here, a new replica server with identical specifications to the primary can be provisioned. The binary log streaming is set up, and a separate connection string for the replica is provided. In this way, you have seen firsthand how simple it is to provision a Vultr managed MySQL database cluster and connect it to your live application, all while Vultr handles the complex operational task behind the scenes. Beyond MySQL, Vultr managed databases extend this operational simplicity to PostgreSQL, Balky, and Apache Kafka. For detailed implementation guides and configuration options for each database engine, refer to our product documentation linked in the description of this tech talk. To summarize, we have explored how Vultr Managed Databases for MySQL provides production-ready MySQL clusters with built-in replication, automatic failover, scheduled backups, and monitoring capabilities so you can focus on building features instead of managing servers. If you are ready to evaluate this in your own environment, you can start by provisioning a managed MySQL database cluster, connecting it to your application, and testing scaling, backup restoration, and monitoring workflows by claiming $250 in free credits on a new Vultr account using the promo link attached in the description below. To participate in discussions or ask questions, join the Vultr community forum. Thank you so much for tuning in. We hope this tech talk helped you gain understanding of how Vultr Managed Databases for MySQL simplifies database operations without compromising on control and performance.